we're going to talk about rates of change. So rates of change, you've been talking about for a really long time. We talked about it yesterday. A rate of change, the average rate of change between any 2 points on the graph of f of x is just the slope between those points. I opened the wrong thing, though, because I can't write if I open the PDF. I need the Word document. So this should be slope right here through those 2 points. So this formula right here should be familiar to you. Probably when you learned it in Math 1, you called it the slope formula. What you're going to see in Precal is they call it the average rate of change a lot more often than slope. So when you see average rate of change, think slope formula. That's what you're going to be looking for. So when you're looking for that, you need to find the y values of the function for the given interval, and then find the slope between those 2 points. So we're going to look at this several different ways because I talked about it yesterday. Understanding like multiple representations of how to do the same math is really important. So we're going to start off here with example 1 is a like an algebraic example. We don't have a graph, we don't have a table, we are just looking at the variables. So in this case, they're asking us for the average rate of change on the interval from -2 to -1. Okay, so -2 and -1, that's my interval that I'm looking at. Those are both x values, right? In order to find an average rate of change, I need both coordinates. I need an x and a y coordinate. How do I find a y coordinate if I have the x? James? Yes, plug it in for the x. Yeah, so I will do f of -2 will be -2 cubed. Arithmetics? Great. Let's see. You got late work bathroom passes. Let me give you your notes here. You are right here beside Luke. And after class, I'll get you the other stuff you missed yesterday. And we've just barely started, so you're not much behind. All right, so we're plugging this in. We got to have +3 times -2 here. A lot of our test is calculator inactive, so like these first couple, I would expect you to be able to do those without a calculator. Right here, -2 to the third is what you have to do first there, order of operations. You got to do those exponents first. So -2 times -2 times -2 is going to give us -8. But you do have this negative that's still out here, so it's -8. And then this will be -6 right here. And when I have a -8, what is that really? That's just +8. So this is going to end up giving us 2. So we plugged in -2 for our x coordinate. We got out a +2 for our y coordinate. So that's our first point there. And then we just do that same thing again with our -1 to get our second point. So we've got f of -1, and we'll have -1 cubed plus 3 times -1. And so I've got -1 cubed is -1 times -1 times -1, which is -1. And then that'll be a -3. -1, -1, just like it did with the 8, is going to become +1, and we'll get -2 for that. So the coordinates for this point are -1, -2. And no matter what equation you have, that's how you can find your y coordinates there. Once you have these 2 points, you're just going to pick one to be your first point, the other one to be your second point, and you're going to plug it into slope formula. It does not matter which point you use for your first point and which point you use for your second point. So, like, for example, I might want to choose, like, this one as my x1, y1, and this one as my x2, y2. The only thing you have to make sure of is if this is your x1, this has to be your y1. It cannot be your y2 for that. They've got to match up. So whenever you do this, I would do -2 minus 2 over -1 minus -2. So make sure everybody's following there. I know slope's a concept you should have seen a bunch of times, but it's been a while. So -2, that goes right there. That's your y2. And then this is your y1. That's the 2 that goes here. The -1 goes right here. And the -2 goes right here. Always minus signs in between them. Although in this case, in the denominator here, since you got that double negative, it becomes a positive. So you would have -4 divided by 1, and that is just going to give you -4 as your slope. All right, I'm going to have you guys try B on your own. You are going to run into some fractions. You are not allowed to use your calculator on them. Let's test your fraction knowledge here. So, try that. We'll freeze the screen up, but there's going to be a big gap with these notes today. So, all right. Pause it. I forgot to put it back. Okay. All right. So, if we want to do this same thing for the next point, actually, first I want to do this. I'm going to graph those points. 1, 25.1, and 1.1, 26.571. Alright, so graphing those points, you can see right there, we're finding the slope of that like little line right there. If I want to graph the equation of that line, which you may or may not know how to do, I'm just going to do it real quick. Like that blue line right there is the slope. That's the line we're finding the slope of, right? What you'll notice is out here, it looks a lot different than the parabola, right? Like that line is definitely a straight line. The parabola curves. But if I get really close, I can barely tell any difference between the line and the parabola, right? They're really close. Now, what I can do is I could get even closer. Like, if I get a smaller interval, I'm going to be even closer to that instantaneous rate of change. So, you'll notice right here, this says 1 and 1.01 right here. So, let's do this mostly with Desmos. It makes it a lot easier. So, watch this. This is pretty cool. I'm going to change that. The 1 stays the same, right? And H is 1.01. You could even do this. Instead of doing like 25.251 minus 25.1, you could do H of 1.01 minus H of 1 over 1.01 minus 1, like that. And it will give you the slope, or you could do it with the values, 25.25151 minus 25.1 all over 1.01 minus 1. Like that. Either way, it'll do that for you. So that'll give you your slope. So whenever we get like closer, my slope is 15.151. So the reason I like this right here is the next one asks me about 1.001. So if I want to change that here, I could just put that extra 0 right there, and it'll change my answer for me. Like, it makes it quick to do that, right? So this next one is going to be 15.195. So 15. Okay, it didn't ask me to do this, but I'm going to. If I want to get closer and closer and closer, I could just keep adding more zeros in there, right? Like make it 0, 0, 0, 1. Now I've got 15.19951. And then if I wanted to add another 0 in that top and bottom, 15.199951. And then if I add 2 more zeros in the top and bottom, look, I just keep getting more like 9s, right? 0.19999. I also could look at the slope. Here they want me to look at 0.999 and 1. So if I go over here to Desmos, let's change this to 0.999. It really doesn't matter which order it's in. Right there, I get 15.2049. So what we're seeing here is like, when I started off with a little bit bigger interval, I got 14.71. Then I got 15.151. And then 15.1951. And then I didn't write it down, but if I put like 1.00001, it was like 15.1999999, right? This one I was like on the other side. I was below the line instead of above. And I got a slope a little above 5.2. So based on this example, what do you think might be the true rate of change in the height of the ball at t equals 1? I'd say it'd be about 15.2. And that would be, I think, well, they didn't really give us units. This is meters per second. Oh, they did, meters per second. So if we use like really tiny intervals, we can estimate what exactly that is. Okay, so the rate of change of a function at a particular point, or what we'll call later in calculus the instantaneous rate of change, is that rate of change at that one tiny instant. And so there are going to be 2 ways that we can estimate this in pre-calculus. When we get to calculus, we'll be able to find it exactly. But in pre-cal, we can only estimate. The first thing is by doing what we just did, and it's by finding the average rate of change over a small interval. So this blank right here should say we can estimate the rate of change at a point by finding the average rate of change over a very small interval. That's what we just did. So we went really close to 1 and found the average rate of change, and that was pretty close to what we would have. Another way that we can look at it is we can estimate rates of change at 2 different points by estimating individual rates of change using the concept of a tangent line. The concept of a tangent line, you should have heard this in Math 3. When you heard tangent lines in Math 3, it was with circles. So if I have a circle, what does a tangent line look like? What do you think, James? Right, you touch the edge of the circle just at one point. So it just like brushes up against the circle, right? So the idea of a tangent line can apply to more than just circles. So if I have a function that looks something like this, I could go in there at a certain point and I could draw maybe like right here. I could draw a line that just touches that curve at one single point. Now that is going to be locally, because if you look, like probably these are going to cross way out here. So that tangent line is tangent at that point. It doesn't mean it can't cross it somewhere else. With a circle, it would mean it can't cross it somewhere else because of the way a circle looks. But it'll touch at one little tiny point right there. So if you can find the slope of this line perfectly, then you can find the slope of the graph, which we'll look at probably a little bit tomorrow. We're not going to get to that today. We're going to do this one last piece for example 5. And And that'll get us right to where second period stopped, and I'll give you your assignment that you'll have. So, we have already talked about this a little bit in the chart that we keep making, right? If F has a positive rate of change, then the graph of F is increasing. If F has a negative rate of change, F is decreasing, right? So we talked about that in the warm-up. We talked about it in that chart that we've been using. It's just reminding us of that here. So what they've asked us to do in example 5 is they have given us scenarios, and they're asking us to tell us whether we'll have a positive rate of change, which means the graph will be increasing, or a negative rate of change, which means the graph will be decreasing. To me, it is helpful to actually draw the X and Y axis and label them and think about what should happen here. So, a child's age versus the child's height. So if I do an XY axis here, I'm assuming that he intended for the first one to be our independent variable, the second thing that he gives us to be a dependent variable. So child's age here and height. So as age increases for a child, what should happen to height? Should go up, right? This graph should look something like this, right? And so that is going to be a positive. I'm going to use ROC for rate of change. I do not mind if you use this on notes or in homework, but please don't use it like on a quiz or a test, and definitely not the AP exam. There's a good chance they'll take it on the AP exam, but if they decide they don't want to, then it would be a shame to lose points because of that. So, I don't mind shortcutting it here, but try not to shortcut it later. All right, let's talk about this one. A golfer's skill level. So skill goes here, and golfer's score. So as you get better and better, do I have golfers? Who's my golfers? Cameron. All right. As you get better and better at golf, what should happen to your golf score? Should go down, right? It'd be the opposite of most sports, right? The better you get, the lower your score gets. So as you get better and better, your score should go down. So if you take somebody like myself, who would be skill level 0 right here, that score is going to be pretty high if you take me out to the golf course. But if we take Cameron golfing, his skill level is going to be over here, his score much lower. All right, so that would be a negative rate of change. All right, this last one is a doozy. It seems easy, and you might even guess it right, but be thinking of it wrong. The height from the ground of a coin dropped off the Burj Khalifa versus the speed of the coin as it falls. Okay, first of all, what is the Burj Khalifa? Tallest building in the world. It's in Dubai, and it's super duper tall. So we're dropping a coin off of a really tall building. Immediately, what are you thinking about rate of change for this? Like, what's your guess at first? Positive or negative? Positive. Okay? Because it'll get faster and faster because you're thinking about speed. I think negative when I guess at it. What I think, though, is negative because I'm thinking of height for dropping. Both of those thoughts are wrong. Because it's not asking you to think about like what you would normally analyze on this. So think about what's on your x-axis. Height from the ground. And then speed of the coin. So if we think about graphing this, you almost have to start backwards to graph this. Because when you drop the coin, is my height high or low whenever you begin? The height is very high. So that would mean, like, whenever we drop the coin, the height would be very high, and my speed would be 0 because I haven't dropped it yet, right? So I'm starting, my scenario starts over here. Okay, now when I drop the coin, several of you said it's going to fall faster and faster and faster, and you were correct about that. But if we think about graphing those points, whenever it drops, its height drops, but its speed goes up, right? So its height drops and speed goes up. Height drops, speed goes up until it hits the ground. Height is 0, speed should be the highest at that point. Now, there's a chance it might hit like terminal velocity and level out. I'm not sure what a coin is going to do from that sort of height, but in general, we're going to see actually a negative rate of change in this. But it's not really because either one of those like things that we were thinking before. All right, so we are not done with these notes, which means you are not going to be able to do the whole assignment. So on this assignment that I'm about to give you, you're going to do 1 through 11. It's the first page. You don't have to do this second page. Key should be posted just like last night, so check your work as you go. And we'll go over it tomorrow. And we do get out here at 1:15. All right, is that right? Yes. All right, so you are good to go ahead and pack up. Somebody's bathroom passes are on the floor.